Hey guys, Dex here, that is Yankee Oscar 3, Hotel Echo X-Ray. I've decided to make a little bit of an experiment here using some bandpass filters, because I'd like to use those two ICOM7300 in SO2R configuration. And please be advised that this might be a long video. I will try to explain some things and I will try to share my experiments with you. So those two particular transceivers, one is both of them are using vertical antennas. This one here is using an ICOM Alpha Hotel 4 that it's up on the building and is a remote tuner for a vertical element of around 12 meters high. All my antennas are at approximately 23 meters above ground level. This one here, the top one, it's directly tied to a ground plane antenna that is cut, it's tuned for the 20-meter band. So it's a ground plane that is having the 5.2 meters radiant at around 10 or 12 radials. Okay, so this one here is using an Alpha Hotel 4 that I can tune for from 80 meters to 10 meters, although on the 10-meter band is not a very good radiation pattern, because it's kind of like NVIS. The radiating element is too long for the 10-meter band for the 28 megahertz. This one here is using a monoband antenna that is cut for the 20-meter band. So I've built some bandpass filters to help me to isolate the two. And when I'm saying isolated, I'm referring to the fact that when you are going to transmit on the 40-meter band, your second harmonic will be in the 20-meter band. Basically, 7.007 times 2 will give us 14.014. And that will kill the reception, and not at last, not the front end, probably the front end of the second receiver. Now, by default, as far as I know, and as far as I managed to find out those datas, the second harmonic is attenuated quite a lot here in the ICOM7300. For the 40-meter band, I do remember that it's something like minus 70 dB from the fundamental. So 14.014 is going to be attenuated around 70 dBs at 100 watts. Okay, so this is the data that I've managed to find on the internet. I didn't find something official from ICOM. Those were the measurements made by a gentleman. I do think that he was from Delta Lima, from Germany. So right now, just to be on the safe side, the RF power of the second one is at 0, and the RF power of the first one on the one on the 40-meter band is also at 0. Okay, because it's easier to follow. The idea is that RF power at 0 is around 650 milliwatts, under a watt. So it's good to test something like this. So as you can see, at 600, let's say 700 milliwatts, the second harmonic on the S meter will come quite strong. Even though we are running 600 milliwatts, I will and I'm on a dead band, because the 40-meter band at this hour is almost 1400 hours local time. That would give us It's 12 o'clock. It's 12 o'clock UTC. So the 40 meter band is quite dead in Yankee Oscar in Romania. So I choose this band because it's quite dead. You can see there are some operators that are in the CV area, but I didn't want to disturb the normal traffic, so I will run the RF power to zero and just not to disturb anyone here. But even so, we are going to send a QRL because I had some surprises. I had some surprises when even with 1 watts I've managed to to add some very long QSOs. So let's just be on the safe side. And we are going to call one more just to be on the safe side and not to disturb anyone with this test. Okay, it seems that nobody is there, but you can basically clearly see that without any filters, so no filters are connected to the output of the transmitting transceiver, the second harmonic is at S9. So let's go with some test. Okay, you can see it's at S9. So it's not very funny because putting out around 700 milliwatts, the second harmonic, because the two antennas are very close, and you can also consider it, and it is near field. So the two antennas are verticals, which implies that are omnidirectional, and it will put out the separation, the space separation between them is around 10 meters. The attenuation in HF, in free space, is very, very, very small at those distances. Basically, you'll have to have quite a lot of distance to have some kind of attenuation. It can be calculated, but it's very, very small. So it's not something to be taken into consideration. Let's put again some a test signal. So it's S9 basically, the second harmonic. Of course, probably I'm using low loss RG58 and some decent connectors. But of course, maybe RG58 low loss LL is not maybe the best cable for this kind of application, because probably there will be some coupling between the two cables. I don't know. I didn't measure it. I do not have RF in the shock, so it shouldn't be, but remains to be seen. What I'm going to do now is I'm going to take out, and you have to bear with me here. Hopefully, I'm not going to do some messy work. I'm going to take out the. Let's see if you can see it. The feeder, the antenna from the first receiver, and I'm going to, because we are on 40 meter band, I'm going to stick the 40 meter. I'm going to stick in the 40 meter filter that is having some kind of adapters, SMA to SO. Yeah. So I'm going to stick it into the transceiver. I do think that you already seen the numbers for the filters that I was posting. Let's see. Okay, so that's nice. Snug it a little bit here. Okay, just tied up the SMA. Okay, this will be a little bit of work here to have it. Now we have the inline filter added there, and I will try to show it to you. Okay, we have the inline filter there, the bandpass. So this will have to give me some kind of attenuation on the second harmonic and also on the third, of course. So I know what. Okay, someone is on the 40-meter band, and I scared a little bit. It's just quite loud. So okay. So this will give me some kind of attenuation on the second harmonic. At least I was expecting a little bit more of attenuation, but you will see what I'm talking about. As I said, probably there is some kind of parasitic coupling between feeders. Also, the fact that the bandpass filter is not on in a metal box yet. I don't know. Remains to be seen. But I do not expect to have a wow factor here. So it seems that we will have to, let's look on the scope, and it seems that we will have to move a little bit. Let's go to dot 5 and here on dot 10. Okay. Okay. So let's put another QRL. It seems that somebody is... Just remember that we are not going to disturb anything from here at all. And here I'm putting under 1 watt in the 40-meter band. But let's go, I don't know, dot 2 and see if there's something on dot 4. Just not to disturb... okay. As you can see, there is some attenuation. Previously F2 was at S9 and now is around S7. Okay, going to put up the scope. But it seems that it's not quite enough. Of course, if you are going to put out the RF gain a little bit, of course it will act accordingly. And I'm never running RF gain full anyway, no matter the band. So if I'm going with RF gain a little bit lower, the attenuation will be higher. Okay. So you can also see that using the bandpass filter. So I'm going to increase the power to 10 watts, but this time we will have to be careful and see if anyone is out there, and we are going to listen first. Okay, so let's see. It doesn't seem to be anyone there. Okay, as you can see, the putting out 10 watts, approximately 10 watts, not necessarily 10% means 10 watts out of 100, is going to increase the second harmonic, and it's going to reflect more in here. Remember that those antennas are quite near field. Let's go with the 40 watts. Let's see. It's still manageable. Let's put out the scope and put the S meter back. Okay, the isolation is not good, but remember, both antennas are in the same plane. Both antennas are omnidirectional. There is no directivity out of them. And both antennas are having the same polarization. So I do think that somehow the isolation between those two is quite decent at this particular moment, because without the filter, the second harmonic here would be out of the roof. It would be plus 20. So we are going to increase the power a little bit. Let's go 60. I'm having a little bit of I'm very sure of the power, because I previously tested the filter, and at least I was making sure that it will withstand 100 watts without a problem for quite a very long period of time. So it's not a problem from this point of view. But let's see how everything will go at 60% power from out of 100. Okay, someone is on the 40, so we are going to, let's see here. Let's use the scope and go to 10, and let's see if someone is here. Okay, so the idea is that plus 20 is not that bad, you might say, but it will kill you. It will kill your reception a little bit. So you see, there is a little bit of interference there at this particular moment, but this is for the 60 watts. Let's go to 80. You see, at 80 watts, it's already started to overflow. Okay, so at 80 watts, so we are going directly to the whole full power. You can see that the second harmonic amplitude did not increase very much, because it's logarithmic, of course, and it's assumingly 6 dB, but what I've heard is the ICOM is 3 dB. So again, information that I cannot actually verify, or at least not in a very easy way. So I will also show you the spectrum, as the second harmonic is at 100. The fundamental is 100 watts, and the second harmonic should be at least 70 dB less, plus the attenuation from the bandpass filter. It's not that bad. It's compared with a very strong station that is coming to you. It's not that bad, but it could be better. It could be better if, for example, I would change the planes of the two antennas. So one one it would be vertical, and another one it will be a horizontal wire on this transceiver that would be connected to the Alpha Hotel 4 remote tuner. I don't know, remains to be seen. I should have a separation of around minus 20 dB from there, and another 38 measured from the filter. It should be okay. Even in this case, like right now, it's not very bad. It's not very bad. Okay, you can actually use the tuner, and I can actually tune the vertical antenna as long as I'm using the correct bandpass filter for the band I'm in. But those filters will be in a box and will have band decoding, and probably as the next step it will be to either to add another filter pole here to add a little bit more of attenuation, because the insertion loss in the Butterworth is it's very nice. I managed to put out some very nice and low insertion loss in the filter, so I can actually add one pole or two. And another thing is that it will be band decoding, and it will be the filters will be switched without any problems by the transceiver, and it will switch the necessary band. So I wouldn't go and put out 100 watts of RF power without a band filter and listen to the second harmonic here on the second receiver. So I wouldn't do that. Not in 1,000 years. Not without a bandpass filter. Probably it will take without any problems, but I wouldn't want to risk that. So this is also kind of a, I don't know, safety net, if you like to call it like this. As I said, it's not bad, but it's not necessarily the best solution at this particular point. So probably I will go out and add a couple of poles on the filters and see how it performs after that. This particular moment, let's see. So it's not that bad. If we are going to use in SSB, if you are going to use the AGC as slow in the SSB, probably the recovery after this interference will be a little bit slower. But for CV, the recovery is very fast. Okay, so the recovery is quite fast, and it should be okay. It should be okay. So those are my findings, at least for now, regarding this matter. I hope you will find it interesting. I don't know. I just wanted to share this with you. If you have comments, of course, I will take it. This is my first experiment of this kind, so probably I will have a lot to learn and a lot to experiment to actually come to a good result. For two verticals, as I said, in the same plane, having the same polarization, and the distance between them is less than 10 meters, I do think that it's quite an achievement at this particular point. So I do expect to have it a little bit better if I'm going to add more poles on the filter, but we will see about that. So thank you for watching this, guys. Wishing you all the best, and 73 from Yankee Oscar 3 Hotel Echo X-Ray. All the best. See you in the air.